Hello and welcome. Today, we're going to dive deep into a material that's genuinely changing the game in modern architecture. It's called glass fiber reinforced concrete, or GRC. We're going to break down exactly how it's made using the incredibly popular spray method, a process that takes a pretty simple cement mix and turns it into these amazing high-performance building components you see everywhere. But before we get into the nuts and bolts, let me just ask you this. What if concrete didn't have to be, well, concrete? What if it could be super thin, crazy strong, and you could shape it into pretty much anything you can dream of? What could we build then? Well, that's not a fantasy. That's the reality of GRC. All right, so let's get right into it. What exactly is it about GRC that makes it such a revolutionary force in construction? Okay, so at its heart, GRC is what we call a high-performance composite. It starts with a mix that's pretty familiar, right? Cement, some fine sand, and water. But here's the secret sauce. We mix in these tiny, specially engineered, alkali-resistant glass fibers. And trust me, these little fibers change everything. Here's where the magic really happens. You see, regular concrete is fantastic when you squeeze it. It has incredible compressive strength. But try to pull it or bend it, it cracks. It has very low tensile strength. The glass fibers, they give it that missing piece. They allow the material to flex and bend without breaking. You're literally getting the best of both worlds in one amazing material. So you're probably wondering, how do we actually make this stuff? Well, let's pull back the curtain and take a look at the essential recipe and the specialized tools you need for the job. Now, looking at this recipe, there's one thing I really want you to focus on. See where it says alkali-resistant glass fibers? That AR part is non-negotiable. You see, cement is highly alkaline, and it would just eat away at regular glass. These special AR fibers are designed to last for decades, ensuring the GRC stays strong and durable. Of course, we also add polymers and other admixtures to fine-tune it for strength and workability. And here are the tools of the trade. You need a high shear mixer to get that perfect creamy slurry. But the real star of the show is the concentric spray gun. This piece of equipment is an absolute marvel. It's what lets us shoot the cement slurry and the glass fibers out at the same time, which is the whole secret behind the spray-up method. Which brings us right to the heart of this explainer, the actual step-by-step process for making GRC. Let's walk through it. It's a very systematic process. You prep the mold, you mix your slurry, and then the magic happens. Simultaneous spraying. Imagine this. The spray gun is shooting out the cement slurry, but at the exact same moment, it's feeding a continuous rope of glass fiber into a chopper that cuts it into small pieces and fires it directly into that cement stream. They hit the mold together, creating a perfectly integrated composite, layer by layer. It's really something to see. But wait, spraying is only half the battle. This next step, compaction, is absolutely critical. You can't just spray it and walk away. Right after spraying, workers go over the entire surface with these simple handheld rollers. What they're doing is squeezing out any trapped air, making sure every single glass fiber is perfectly encased in cement and creating a super dense, strong panel. You can't skip this. So we've seen how it's made, but let's talk about why this is so revolutionary. What are the incredible advantages that have architects and designers so excited about GRC? I mean, this chart says it all, doesn't it? When you put GRC head-to-head with old-school concrete, it's no contest. It's incredibly lightweight. You can make elegant panels that are only 10 or 20 millimeters thick. It's got that high tensile strength we talked about, and here's the big one for designers. You get almost total design freedom. You're not stuck building boxes anymore. Let this number really sink in for a moment. 1/4. GRC weighs about a quarter of what traditional precast concrete does. That single fact creates this incredible domino effect. It means you need less steel in your building's frame, it means you need smaller foundations, it means it's cheaper to transport, and it's faster and safer to install. It's a massive win for efficiency and sustainability, all from one material. And with that kind of lightweight strength, a whole world of possibilities opens up. It's the go-to material for these beautiful, intricate facade panels you see on modern buildings. But it's also used for everything from ornate columns and cornices to massive domes, mind-bending sculptures, and even things like durable, stylish benches and planters. So what does this all mean for the future of building? Look, GRC isn't just another product on the shelf. It's a tool that is fundamentally rewriting the rules of how we design and construct our world. It's freeing architects from the tyranny of the straight line. Buildings don't have to be rigid boxes anymore. They can have flowing curves, gentle waves. They can look like they grew right out of the ground. And the level of detail it can capture is just insane. Because you're spraying it, it's almost like painting with concrete. It gets into every tiny nook and cranny of a mold, perfectly recreating complex patterns and fine textures. So what you get in the end is the ultimate combination. You get structures that are light on their foundations but incredibly tough and durable enough to stand up to the elements for decades. It's pushing the boundary of what we all thought was architecturally possible. And that brings us full circle, right back to that first question. GRC shows us what's possible when we remove the limits of a material. So I'll leave you with this thought. If our building blocks are this flexible, this strong, and this light, what are we going to build next? The possibilities truly are endless.
Concrete tech where knowledge is strength.